This video is on Unit 5, Chapter 11, Graphing and Solving Rational Functions, Lesson number 3, Variation Models. So in your notes here, under Variation Models, it says that variation is a special relationship between variables. Sometimes we can have a direct variation, and it says that y is directly proportional to x. The equation that we have for that is y equals k times x. K is the constant of variation. So it's like the multiple. Think of it as the multiple in that situation. Then we have something called joint variation. Y equals k. There's that k again. But we have joint. So there's two other things that are related. So y equals k times x times z. Y varies jointly as x and z. And then we have something called inverse variation, where y is inversely proportional to x. So y equals k over x. And the way that I try to help kids remember this is that think of inverses. When we talk about inverses, one's in the top, one's in the bottom. Okay? So the y is whole, the x is in the bottom of that fraction. They're inverses of each other. Again, k is your constant of variation. So in this next section, it says in the directions to determine whether the equation represents a direct, joint, or inverse variation, and then identify the constant of variation. I'll give you a little hint. In order to determine what k is, it's easier if you've got it set to y equal, okay? And that goes for every single one of these. So on number 1, we've got y equals 2x. So that is a perfect y equals kx. So this one is an example of direct variation, and k is equal to 2. So let's look at number 2. Y is equal to 24 over x. So that is a perfect example of inverse. It's set up as your y equals k over x. So this is an inverse variation. And in this instance, k is equal to the 24. Number 3, y equals 5 times x times z is a perfect example of your joint variation. Y equals k times x times z. So this is the joint variation, and the k is equal to 5. Number 4 doesn't say y equal. So I'm going to divide both sides by 3. Y equals x over 3, or you could write this as 1/3 x. And what that's going to show you there is that's y equals kx. Y equals kx is a direct variation where k equals 1/3. So again, it is easier if you make these say y equal. A little hint here, when I look at number 6, I see a y and an x and a z. So I do realize that that is going to be joint, but be careful. It doesn't say y equal. This is a joint variation. But the k, you might think that it's the 4/3, and it's not. Because it needs to say y equal, I'm going to multiply by the reciprocal on both sides. And now it says y equals 3/4 times x times z. So that's y equals k times x times z, and k equals 3/4. So just be careful. The moral of that story is be careful. Let's move on down to the word problems here. Let's look at number 9. For direct variation examples, if y is directly proportional to x and y equals 28 when x equals 7, find x when y equals 52. So The way I like to set these up is as a proportion. And I want you to think of directly proportional. So y equals k times x. So it says y is directly proportional to x, and y is 28 when x is 7. Find x when y is equal to 52. So there's a couple of different ways I can show you how to do that. One way is to find k. So take that first part. If y is directly proportional to x and y equals 28 when x equals 7, I'm looking for the value of k. So divide both sides by 7 and we get k is equal to 4. So I'm going to use that when I go to this next section of the problem. It says find x when y is 52. So again, using this direct proportion, y is 52. I'm trying to find x, but I now know that k is 4. Divide both sides by the 4. And I get x is equal to 13. So it's kind of like a two-step process. Let's look at number 10. If r is directly proportional to the square of s and r equals 72 when s equals 12, find r when s equals 8. So I'm going to use the same kind of idea here, but we've got to go back to how this is read. If r is directly proportional to the square of s, so r is directly proportional to the square of s. So writing that, it would be r equals k times s squared. If r is directly proportional to the square of s and r equals 72, so I'm going to use that equation and plug in my 72. When s is 12, we're gonna find k first to then find the r. So 72 is equal to k times 144. Divide by 144, and we're gonna get k is equal to 72 over 144. One half. So k equals 1/2. So then we go to the find part. Find r when s is equal to 8. I now know that k is 1/2 and s is 8. So 8 squared is 64. Half of 64 is 32. So r equals 32. Let's move on to this next section, joint variation examples. If y varies jointly with x and z, and y equals 48 when x equals 8, and z equals 15, find y when x equals 14 and z equals 20. So here again, I need to find the value of k. Read that first part first, and it's going to tell you how to set it up. Y varies jointly with x and z. So that's your y equals k times x times z. So we're going to take the first pieces of information, plug those in, find k, and then use that to find the y in the end. So y equals 48 equals, I'm looking for k, x is 8, and z is 15. So I need to multiply 8 times 15. So 8 times 15 is 120. So 48 equals k times 120. We're going to divide both sides by 120. So 48 divided by 120 and we get 2/5. So K equals 2/5. I'm going to use that then. Go to the second part of this question. It says find Y when X is 14. I now know that K is 2/5. X is 14 and Z is 20. So all I have to do now is multiply the 2/5 times 14 times 20. And I get 112. Right, let's look at number 12. So on number 11, that flowed right with the notes that I gave you in the very beginning. Okay, so that was right along there with how this was given, that joint variation. But the next one is not. Let's read it carefully. If P varies jointly as Q and a cube of R. So the way this one's going to read, P equals jointly as Q and the cube of R. So R cubed. Now we can plug in the information that we know to find K and then use that to answer this last question. So P is 270. We're looking for K. Q is 6. R is 3. So 3 cubed is 27. And 27 times 6 is 162. So this is 270 equals K times 162. And then we need to divide by the 162. So 270 divided by the 162 is 5/3. So K equals 5/3. I'm going to use that to find P. So find P. K is 5/3. Q is 3. And R is 5. So I'm going to plug in 5/3 times 3 times 5 to the third power. 5/3 times 3 times 5 to the third power. And I get 625. P is 625. All right, let's jump down to the inverse variation. Number 13, if Y is inversely proportional to X and Y equals 7.5 when X equals 8, find X when Y equals 5. So again, this is your inverse. Y varies inversely to X. So that's your Y equals K over X. And that's what we're going to use here. Y is 7.5 when X is 8. So I'm going to use my proportions. K is equal to 7.5 times 8. And I get 60. So K is equal to 60. Find X when Y is 5. So Y is 5 equals K is 60 over X. And using my cross products, 5x equals 60, divide by 5x equals 12. And number 14, if M is inversely proportional to the square root of N, and M equals 27 when N equals 16, find M when N equals 64. So again, we're going to have to write this in relationship to what it's given. M is inversely proportional to the square root of N. So there's your equation that you're then going to use to answer this question. M equals 27, so substituting in the 27 equals, I'm looking for K, N equals 16. Well, the square root of 16 is 4. So 27 is equal to k over 4. Multiply by 4. And we get k equals 4 times 27 is 108. So k equals 108. Find m when n equals 64. So substitute in my k, and n equals 64. Well, the square root of 64 is 8. And 108 divided by 8 is 13.5. And I'm okay with a decimal there. All right, let's jump down to combined variation. A combined variation is a relationship that contains both direct and inverse variations. So let's look at number 16. We've got to figure out how to write this. It says y varies directly as x and inversely as z. So y varies means y equals. It's directly as x, so that's kx, and inversely as z. So that's how you would write that one. Let's look at number 17. P varies inversely with q squared and directly with r cubed. So again, P varies, so P equals. We've got direct and inverse, so I know I'm going to have a fraction. It's inversely with q squared. So the q squared goes in the denominator because that's the inverse part of this, and directly with r cubed, but don't forget your k. Now let's look at number 18. It says that A varies directly as B and inversely as C. If A equals 16 when B equals 12 and C equals 6, find A when B equals 28 and C equals 4. So this one is very similar to all of the other word problems that we've been working on. We first have to write the rule. So looking at this first part, we've got to write the rule. It says A varies, so A equals directly as B, so K times B, and inversely as C. So C is what goes in the denominator. So in this first part, again, you're just trying to find K. If A equals 16, when B equals 12, and C equals 6. So to solve this, a couple of different ways. I would probably, that K times 12 is the same thing as 12K. And 12K divided by 6 is 2K. That's where my brain went. So I've got 16 is equal to 2K. Divide both sides by 2, and you get K equals 8. You may not have solved it like that, which is fine. Whatever method you want to use there to get K equals 8 is great. So now we're going to find, now we're to the find part of this. Find A, going back to the equation that we wrote, A equals, when B equals 28 and C equals 4. So again, you just found the K, so don't forget that. So I have 8 times 28 over the 4. So 8 times 28 over the 4. And I get 56. So A equals 56. All right, those are your notes for Chapter 11, Lesson number 3.